Oakland Robotics Association, and you're watching Cloud.
I'm the president of the Oakland Robotics Association, and what we do is we build autonomous ground vehicles to enter into the yearly intelligent ground vehicle competition that's held on Oakland's campus. The competition, you design a robot that has to drive completely by itself, no human intervention whatsoever. So what it has to do is it has to identify painted white lines in the grass with a camera and avoid them, but also at the same time detect and avoid physical obstacles like trash cans, construction barrels. I'm in charge of software, vision systems, and some artificial intelligence. Although we share that job, we all pretty much get together and kind of brainstorm how to control the robot intelligently.
I'm going to wire it, and then I'm helping do the basic design, the physical structure of it.
I do the mechanical engineering aspect of it. I deal with the hardware and basically the machining and all that type of stuff, yeah.
I built the upper frame of the robot, which is the higher level electronics, and also helped design and build the whole robot.
Yeah. I was involved in designing and developing the obstacle navigation algorithm. What's obstacle navigation is, at the competition we have several obstacles and the robot has to drive through all the obstacles without even touching them. So the sensor on board gives me the information of the obstacles that are around. And then once I get the obstacle information, I choose the right path, and which we call the safe path. And also I designed vision a bit along with the meter, and was also involved in the embedded control part, which we call the drive control of the robot.
So I was involved in deciding the parts for the computer, the motherboard, the processor, memory, so that it doesn't eat up too much battery power. So we can get the right combination between power and performance. So I was working on that, and also I worked on the controller for the robot, so that when the robot is actually not performing in the field, you can move it around. So we actually got a PlayStation 2 controller, hacked it out, and so that it works with our robot.
Well, we have mostly engineering students, but we also try to get other majors in to help promote our organization, make graphics for our organization. But we need all kinds of engineers too. We need electrical engineers to design the software, wire the robot, design all the power systems. We need mechanical engineers to help us design the suspension systems, frame structure, everything. So we try to encompass as many majors as possible to make it as a well-rounded team as possible, so we can do anything, not just electrical work, not just mechanical work, not just publicity, but have all of them together, yeah.
Class is all about learning the theory, and then you really don't have enough time to apply the theory into something that moves. And Robotics Association is a great place where you can actually implement that theory and actually see that theory working. So it's like visual, that you can see everything is, hey, what I learned in class is is right here, it's working. It's just not mathematical numbers anymore. It's actually something that does something.
Well, this club is very good because it brings people together from all different backgrounds, and especially for the new engineers or the freshmen or the juniors, it would be very good to join because of the fact that you would have a little bit more seniors working in here, and we all are from different backgrounds as far as engineering goes. We have electrical engineers, mechanical, computer, all different kinds, and they would get a very, very good experience as far as working together as a team and once in a while you get a chance to shine, do your own thing. So
It's mainly the real world experience. It takes knowledge from the classroom. I mean, they have to know that, and then they have to be aware of technologies, which is fast-paced development out in the real world. You gotta keep up with that, and you gotta use it to build a system, and that's the main thing. Students that graduated from the projects they do for the competition are very confident in solving problems. They are not shy in fixing things or building things and designing new things.
It's everything, but most enjoyable parts when you spend hours, days, weeks testing one system, and then it finally works the way you finally wanted it to, and then you get to watch it do its thing by itself. You don't have to interfere with it. That's the most enjoyable part. Yeah, when it finally, it's like a child. You're training the child, and then it's doing its own things. You just get to watch it. Yeah.
Hi, welcome back to Club. My name is Aaron Siegel, and today we've got Micho from the Robotics Association here at Oakland University. Today we're looking at it at their IGBC robot here at Oakland. What do we got here? Show me what makes this robot do what it does.
Well, we have this thing drive itself. We don't have to interfere with it at all.
Not at all. Like it has its own intelligence that guides it.
Yeah, it detects obstacles by itself, sees obstacles with the camera. It's not on here right now, but
If it was on there though, it would know that I'm standing right here, not to go towards me, right?
Yeah, exactly. Yeah, it'll never hit anything.
Wow.
That's if there's no bugs. So we're working it out.
Well, yeah, you have to work that out. But
Bugs are everywhere. So what's special about this robot are the wheels. They're built like normal wheels. They have rollers instead of tread.
Yeah, I noticed that. What's that for?
What that allows the wheel to do is push diagonally and rotate instead of straight. And by controlling each of the wheels separately, you can actually control the direction of the robot. You can go
So this robot, in addition to going that way and turning, but it can go completely side to side.
Side to side, anywhere in between two diagonally.
Wow, let's take a look at this. Let's see this in action.
So again, so you can go
We got forward,
reverse,
there's reverse.
right, and we got diagonal as well.
Nice. So it doesn't turn like the car turns at all. The wheels don't change direction at all. You just change speeds of various wheels.
Yep, and I just adjust the amount of force that you apply in each direction, and that can move any direction. Also rotation.
Very nice. Well, it kind of looks like you guys have stolen my personal laptop or something to this. What system? What systems are you running? You running Windows or are you running
Windows XP? Yep.
Oh wow.
It's basically the brain of the robot.
Okay.
All the other electronics you see on there are just the nervous system and muscles, if you will. It's like an animal or a human being. The brain is the laptop. It interprets all the sensor readings and generates the commands that move the wheels and stuff.
So now everyone has built this thing like from scratch. All you've gotten is parts, you've welded them together and put everything together from design to reality.
Everything's from scratch. All our team members, different systems.
All students?
All students, yeah. Some about half and half graduate members and the students. Yeah.
Oh,
the only thing we bought ready-made were the wheels. We didn't build the wheels, but we built everything else. The whole frame. We wired it ourselves, programmed everything ourselves. Everything is pretty much handmade.
Well, the wheels seem pretty extreme though. Did you see any of those in a lot of competitions or?
Again, we're the only team that uses these in OUTV. So we have the extra mobility of going sideways that other teams don't have. So
and that would definitely be a good advantage going around objects.
Yeah, it provides a good advantage to it.
Well, I've been told that I get to maybe even drive this thing a little bit and see what happens. I mean, I'm very comfortable with the PlayStation 2 controller here, so it does look familiar at least.
So the left one controls translation. So if you push this one up, it goes forward.
Okay.
You can push it backward. And then push it to the left, it moves left. Push it to the right, it moves right.
Okay.
And then this one rotates. So it can go this way, it turns clockwise, this way it turns counterclockwise. And then you can do combinations of all too.
Oh, very nice. What am I working with the buttons here?
Nothing. Yeah, it's just the joysticks.
Just joysticks?
Whoa, be a little gentle with it though, yeah.
It's a very sensitive control.
Yeah.
Wow, this is definitely not like driving anything I've ever driven before.
Yeah.
Now, when you put it on full rotate, you can pretty much how do you guys remember which one's the front end and the back end? You guys, the left half's the back, right?
Yeah, the one with the red switch is the back end. Yeah.
Okay, so when building this thing though, you guys said you ran into bugs every once in a while
Yeah.
and the likes. Like what did you encounter when you guys were building this?
No, the first thing is just being able to do this, and kind of comes by translating the commands you take from the joystick to the wheel speeds. So that was our first step, get the drive control ready so we can do this.
Okay.
After we get this working, then we start adding the sensors and everything that we can do autonomy.
Well, it's quite obvious that you need a lot of experience to learn how to drive this thing very basically and keep it within any lines, much less, I don't think I could drive this thing down a 4-lane road, much less a little road, that chalkway that they have to go through for the competition itself. So I'm going to hand off the controls to someone that actually knows what they're doing, and we're going to take a look at what this thing can do.
America's all about hot, nasty, badass speed.